This is the final project presentation. My name is Neo Chanu. My teammates are Devil, Sony, and Tianlin. Our project is about real or not natural language processing with disaster tweets. Before we dive in, let's take a look at the 6 things we'll talk about. First, we'll introduce the problem and the goal of the project. Second, we'll take a look at a high-level overview of what the system architecture is like. Third, we'll take an in-depth look at the machine learning process. Fourth, we'll look at the results of the models we've created. Fifth, we'll take a look at the limitations and summarize the project. And finally, my teammates will talk about the system, version A and version D. The problem. The world we live in today has become increasingly connected. Twitter is one platform where people share their thoughts, and even when they have an emergency situation. Now, it's difficult to manually look at each and every single tweet on the Twitter platform to decipher whether it's about an emergency situation or not. Due to this problem, more agencies would be interested if there was a programmatic way to monitor social media platforms such as Twitter. That way, they can identify emergencies as soon as possible. Thus, the users of our system would be disaster relief organizations, news agencies, and first responders such as paramedics, firefighters, and police personnel. The goal of this project is to analyze tweets. The data set that we're using is from a Kaggle competition that offers a curated data set of Twitter tweets. The goal is to predict which tweets are about real disasters and which ones are not. As a machine learning approach, we've framed it more as a binary classification. So to give you an overview of the system architecture, there are 2 versions that are created, version A and version D. While both of them differ when it comes to the specifics, the underlying structure is pretty much the same. First, the data is cleaned and is feature engineered. Next, it's fed into machine learning models, which are then tuned. And finally, the models are evaluated. Let's take a little deeper look at how version A differs from version D. The data cleaning and feature engineering aspects differ a little bit. Besides that, different machine learning models were used. In version A, we see AdaBoost, Ridge, KNN, and SVM, whereas in version D, we see logistic regression, decision tree classifier, gradient boosting, KNN, and support vector machines. Finally, also the way the hyperparameters were tuned differs slightly. In version A, it was manually tuned versus in version D, grid search was used. Now let's check out the performance. In version A, Ridge model performed the best. In version D, logistic regression did the best. Of course, our class project has its limitations, one of them being generalizability. The data set we used was relatively small, about 7,000 tweets. And also the data set was curated. So therefore, this is the data that it was trained on, so the models may not generalize well to real world data. Second thing to note is in this data set, tweets that were about disasters and tweets that were not about disasters were roughly balanced, as you see in figure B. Of course, in real world data sets, the proportion is going to be very different. Another thing to note is the variability within tweets. We see that in the data set that we used, the average word length, for example, was pretty much the same for both tweets that were about natural disasters versus those that weren't. We also see, for example, the frequency of words in tweets that were about disaster versus those that were not. We see this is the distribution, as you can see in figure Z. But of course, in real world data sets, this frequency and variability of the words used will be different. And finally, another thing to note is the computing resources. Our laptops didn't have enough computation power to run more sophisticated models. Therefore, it's very possible that more sophisticated models may have led to a better performance, but of course at the cost of interpretability and perhaps also at the cost of speed. So finally, let's summarize this presentation before I give it away to my teammates to do the system demo. To summarize, our project was based on a kaggle competition. We used a curated Twitter data set. The problem was that with the enormity of tweets that are being constantly sent at the platform, it's hard to manually look at each and every single tweet to decide if it's about an emergency situation or not. Therefore, the goal of this project was to analyze tweets and predict which ones were about real disasters versus which ones that were not. And this whole project was framed as a binary classification. Next, we'll go to our system demo. First level, we'll introduce version D, and then Dylan or Anthony will introduce version A.
Hi, this is Dawal Salani, and I will present the demo for version D. So as my teammate mentioned, our project is about classifying tweets, whether it is related to a real disaster or not. It is hard to manually decipher which tweets is about an emergency situation. Because of this, more agencies are interested in programmatically monitoring social media platform in order to inform stakeholders and take steps towards emergency situation relief. So agencies such as disaster relief organization and news agencies are interested to identify emergencies as soon as possible by monitoring social media like Twitter. So the users of the system would be disaster relief organization, news agencies, firefighter, paramedics, and police personnel if this system gets deployed. So now I will go through the system demo for our version D. As you can see in our data, there are like 5 columns: ID, keyword, location, text, and target. So text column belongs to the tweets. So in this version, we only we are dropping like keyword and location column, as there are most of them are null. So we are only going to use this column which contains tweets. So, and then we further clean the data. We removed the URLs in the tweets using this regular expression, and then we removed HTML tags, emojis, and punctuations. And then we used word stemming and removed the stop words, as you can see. And then we created the dictionary for the word with their frequencies, and then using one hot encoding. We are using one hot encoding with the scikit-learn library count vectorizer. In this version, I've used like 5 models: gradient boosting, decision tree classifier, KNN, logistic regression, and support vector machine. So among them, we are getting the best accuracy and F1 score in a logistic regression model. That's why we further hyper-tune that model using these parameters and using grid search CV with 10-fold cross-validation. In which we are getting like 78% accuracy for the test data and 71% F1 score. Now I'll show like how we can pass on the tweets and it will give the output. So as you can see, this is the tweet which is about accident. Sorry, which is not about the disaster. So it just mentions about like clearing the traffic clearing due to the accident. So when I run this tweet, it gives output like this tweet is not about real disaster. We have other tweet as well, which is about disaster. So when I run this tweet, the system gives output like this tweet is about real disaster. So so like this, we can deploy this. We can make web version of this system and pass the tweet, and it can uh, show the output whether that tweet is related to the disaster or not. Now my other teammate Anthony would present other version demo. Thank you.
Hi, this is Tianlin, and I'm presenting the version A. Here we can, as we can see in the data, there are 5 columns, which is ID, keyword, location, text, and target. We can see here, location has the most missing value, so we drop the location line and combine the keyword and text together because they are all consist of words. Let me check here. We combine them together, and uh, as, as we can see, there are no much differences in the average word length. So we're not going to use word length as a feature for feature engineering. And here comes the data cleaning process, which is pretty the same with version D. And first is remove URLs and remove punctuations, HTML tags, and remove stop words, remove numbers. And I use lemmatization, and I turned out the we turned out the words into lowercase. And as we can see here, a sentence is when the sentence is clean, we can see here is turned out to be a list of words, and we use Google News model to turn the list of words into a vector, so we can input in our model. Here we use 4 models for testing. First is AdaBoost, and the second reach, and the third is k nearest neighbors, and the fourth is the linear support vector machine. And as we can see the results, the best model is linear support vector machine, but we can see here reach and the linear SVM has a pretty close score, so other one is fine. Here I use I test linear SVM. First, we test the kernel of the linear SVM, decide which is better. So as we can see, the results, the linear is a better way to build the model. And second, we turn the parameters. We can see the 2 is the most efficient with highest F1 score here. Average is like around the 0.72. And we use this model to train the data set and get a accuracy of 0.79, which is good. And here comes to our system. Our system can, like if you input a paragraph of text or several sentences of text, we can give you the results, tells you whether it's a tweet or not, it's about a real disaster or not. Here, as we can see, the first text describes a big fire near some place, and our system can successfully turn out is a tweet talks about disaster. And the second is someone go to Disneyland and tweets about Disneyland. Apparently, it's not a tweet talks about disasters. Our system can successfully give the results of the tweets is not about a real disaster. So this is the model, the version A. That's all.